Welcome to our lectures on flexible AC transmission system. We are discussing about the DSTATCOM. Now, in this lecture, we shall see that actually how to design the DSTATCOM. So, design of the DSTATCOMs include the detailed analysis for deriving this design equations for calculating the values of the different component used for the circuit configuration. So, we require to see that how we can come out with the values of the capacitor, inductor and different component. As already discussed in previous section, there is a large number of topologies of the DSTATCOM. Therefore, it is not possible to include here design of the all circuit configurations and the topologies. So, few major and the commonly discussed topologies is been considered here. In view of the facts, this phase of the 3-phase 3-wire DSTATCOM we have considered, and here we have considered the step by step design of this DSTATCOM. It includes the design of voltage source converter and other passive component, there is a DC-link capacitor and the coupled inductor. These are also the component of it, and we will see that how we will design it properly. So, design of the DSTATCOM includes, let us understand that how we will go by step, interfacing inductor and the ripple filter. Please recall the circuits we have discussed in previous class. Ripple filter is used to suppress the switching frequency at the point of common coupling. So, switching ripples has to be mitigated by the ripple filters, and accordingly it has the value has to be actually the cutoff should be near to this actually the switching frequency. So, you require a very small filter to do that. The design of the interfacing inductor and the ripple filter is carried out to limit the ripple in the current and the voltages. The design of the voltage source converter include the DC bus voltage level, which voltage you will operate, the DC bus capacitance and the rating of the switches. If it is IGBT, then it is IGBT. The design of the DC bus capacitor depend on the energy storing capability needed during the transient condition. So, there is a step change in the load. So, you cannot get instantaneous power from the supply, or you can throw back the instantaneous power from the supply. So, that for this transient time, so this energy storing ability will be considered. Rating of the DSTATCOM depends on the required reactive power compensation and degree of unbalance will be present into the load, because you know that harmonics generally power is generally very less. So, these are the two dominating power that will actually ensure that power rating of the devices. Now, hence this current rating of the DSTATCOM is affected by the load power rating and the voltage rating depending on the DC bus voltage. The design equation of the estimation and the selection of the component of the VSC of the DSTATCOM and the voltage level will be discussed in this section. A 3-leg VSC is used as a distribution static compensator of the topology, has 6 IGBT, minded it may increase for the 3-level inverter or the more level, 3 inductor and a DC capacitor. The required compensation to be provided by the DSTATCOM decides the rating of the VSC components. The VSC is designed for compensating a reactive power of 50 kVA, 415 volt, 50 hertz 3-phase system. This has been considered. So, see that this is the again the STATCOM, and it may also have a reactive power. So, we have considered the 3-phase 3-wire balanced load, but it may have a nonlinear load feeding a diode based rectifier depending on the different kind of possibilities. So, this is basically the LR we require to design, and this is the value of the CDC. Actually, we require to design the value of the capacitor and the value of this DC voltage to operate properly. Please note that since we have seen in case of the STATCOM that it required to inject power, current has to be this way. So, for this reason DC link voltage has to be higher than the rectified DC bus voltage, because it is a 2 quadrant switches. Ultimately, due to this body diode, it will act as a rectifier. Once and it sees inherently the boost topology. Please note that when this lower switch is on, then current will flow through this in positive half cycle, and thus when switch is off, current will be actually flowing through these directions, and thus it will boost the DC link voltage. So, it is this LR is essentially does the two purpose, since it is a PWM inverter. So, instantaneous pole voltage of the inverter will be different from the VSA, and for this reason we have to put an inductor to block the circulating current, and moreover we require to actually boost up the DC bus voltage. So, for this reason we require this inductor. So, see that how we will first we will go by selection of the DC bus voltage. The minimum DC bus voltage of the VSC of the DSTATCOM should be greater than the peak of the phase voltage of the distribution system. The DC bus voltage is calculated as 2 into under root of root 2 V by L by root 3 M, where M is the modulation index and generally it is restricted to 0.8, please mind it. So, where M is the modulation index and it is considered 1, and generally we do not consider 1, rather we considered it around 0.8, and VLL and the AC output voltage of the DSTATCOM. So, thus even if you consider that M value to be 1, so VDC obtained to be 667.69, and if you divide it by 0.8, so it will be actually around 750 volt. So, for this reason we can select the DC bus voltage in and around 700 to 750 volt. This is a calculation. Now, we will talk about the selections of the DC bus capacitor. The value of the DC bus capacitor CDC of the VSC of the STATCOM depend on the instantaneous energy available to the STATCOM during the transients. The principle of the energy conversion thus half CV square. So, half CDC into Vg square minus Vc1 square equal to K1 3V ALT. What is it? Let us see. Where VDC is the nominal DC bus voltage equal to the reference DC voltage, and Vc1 is the minimum voltage level of the DC bus, A is the overloading factor, B is the phase voltage, I is the phase current, and T is the time which the DC bus voltage has to be recovered. So, generally it will be some cycles. So, it will be around 2 cycles, 3 cycles, 100 milliseconds or 150 milliseconds, something like that. So, thus we can put this value. Let us consider that the voltage is been kept to the 700 volt, considering the minimum voltage level of the receiver's voltage. So, VDC was actually 700 volt and V equal to, then we can compute that actually the what will be the phase voltages, that is around 240 volt, and I should be equal to 76 ampere and T equal to 30 milliseconds and A equal to 1.2, and variation of the energy during the dynamics is a K is assumed to be the 10%, and from there we can calculate that what should be the value of the CDC, and it is basically we come out to be this value. So, we can select in the range of the around 13,000 microfarad or 13 millifarad. So, let us then come to the next step of design. So, that is your design of the inductor. Selection of the, we please recall actually design of the inductor is a very important aspect of our design. So, selections of the AC inductance LR of voltage source converter depend on the current ripple, switching frequency Fs and the receiver's voltage, and it is given as actually LR equal to root 3 Vm DC by 12 AF CRR. Let us see what is it. M is the modulation index of the of a switching pattern, and A is the overloading factor. So, how much you can overload. So, depending on you can overload. So, generally it has to be, we have when we put a inductor specifications, we put there are few values for what is its no load value L0, full load value FL, 1.2 into full load value. So, here actually it is considered to be the 20% mode of the full load value. Most of the cases what happen, we know that L equal to N phi by I, and if current increases, thus the value of the inductor decreases, and it has a different kind of material to be chosen accordingly. So, that comes up to the actually the power electronics engineer has to be a very competent to design the inductor for having this loading factor into the account. So, let us consider it is a three-way system, and thus you got this much of the current ripple for 6 pulse converter. You can change this value also to 27%. So, CRR PP is around 15%, and now the switching frequency of the IGBT or IGCT, that is, let us assume that it is operating at 1.8 kilohertz, and modulation index we assume to be 1, and thus and VDC also 1, VDC also 700 volt, and overloading factor said to be actually 1.2, and the value of R is calculated to be the 4 millihenry. We can round it up to 4 millihenry. So, it is chosen for the investigation. Now, next is the selection of the ripple filter. So, ripple filter is essentially a high pass filter. It will suppress the switching frequency harmonic. Here switching is done at 1.8 kilohertz. So, accordingly we require to design the ripple filters. The high pass filter, in order to a high pass filter tuned at half of the switching frequency is used to the filter out the noise or the switching ripples from the point of common coupling. Please note that actually power system is actually predominantly is inductive, thus it is a low pass filter. So, it will be actually eliminate that high frequency noises. And while doing that, we require to choose the time constant should be very small compared with the fundamental time period of t. So, t should be actually much greater than Rf into Cf, and for let us consider that Rf into Cf will be Ts by 10, where Rf, Cf and Tr are the ripple resistances. The ripple the ripple filter capacitance and the switching time respectively. So, we have already chosen that switching frequency of this actually inverter is operating at 1.8 kilohertz. So, thus parameter is selected to be actually Rf equal to 10 and Cf equal to 5 microfarad. So, this is the case. Okay. Now, let us come to the switching. Now, we have to choose IGBT. So, what should be the rating of it? Generally, we consider a factor of safety, and with that there is some data available with the reliability studies. Generally, more the factor of safety you use, you got a more reliability. So, for this reason we have chosen this actually the DC link, it is a 2 level inverter, and the DC link voltage is 700 volt. So, we choose 10% more as a surge voltage rating. So, voltage rating of the device can be calculated in dynamic condition. So, what is it? So, SW will be equal to VDC plus VD, where VD is basically 10% overshoot of the DC link voltage under dynamic condition, and thus the voltage rating of this IGBT should be around 770 volt, but practically speaking you got an IGBT of the voltage level of around 1200 volt. So, we will choose a factor of safety. Generally we expect that this DSTATCOM will be actually will have a lifespan around 10 years, and thus actually this DSTATCOM around choosing a safety factor of around more than 1.5, that will ensure that, and we can choose closest to this value as 1200 volt. IGBT is selected for its PSC rating. What else, and how we will come down to the inductor rating? Current rating also can be calculated. It has few components of it. The device can be calculated under dynamic conditions, and that is basically SW equal to, you have a ratio 1:25 Cp Pp and the peak ratio, and from these equations voltage and current rating of this IGBT can be estimated. So, current rating of the switching in this portion we can go back what was our value of these values of this current. So, we have already seen that value. So, this is the value of the CRPP, and from there we can calculate that what is the value of CRPP and the peak current rating. And from this equation the voltage and current rating of the IGBT can be computed. So, the current rating of the switches is found about to be the 149.59 ampere, and we require to take a factor of safety. In this case generally we find that factor of safety required to be double, and for this reason we choose the next available higher rating, that is 1200 volt 300 ampere. So, these are few takeaways. Now, we have to actually consider few aspects of it. Now, another aspect of it is in a STATCOM how you actually choose, and you will find few practical aspect of it. Then generally what happen, you have a DSTATCOM. So, this DSTATCOM generally we have calculated a huge amount of capacitor. This capacitor value has been calculated. Since it is a very large value, then generally it will be feeded with the electrolytic capacitor. But in practically you will find that with this, and what was the value we have found in the value of the capacitor, let us do the calculation here itself. So, this is the calculations. We find that value to be the 13 millifarad. So, you have a 2 level inverter. Thereafter, you will find that there is a actually few capacitors, one is ceramic capacitor, one is tantalum capacitor, another is electrolytic capacitor. These have been placed. So, you require to also calculate their values here. What happened? So, this value is corresponds to this electrolytic capacitor, and ultimately you have a small tantalum capacitor and you have small ceramic capacitor. Generally the ceramic capacitor will be just 5% of this big 13 millifarad capacitor, that is very low, and 0.5% of it should be the tantalum capacitor. What does they do? Essentially there will be a leads, and due to that there will be an inductor, and thus even though you cut this leads practically, we are talking about the few practical aspects, this course is fact devices. So, we have to cut this lead at the junction. So, this lead may gives rise to the inductance. That inductance required to be suppressed. So, for this reason we have a switching, and these leads may be actually acts as an inductor as a switching frequency. So, to suppress those we have to parallelly connect this ceramic capacitor CE and the CT, and what will be the placing? Generally there is a way of placing this capacitor, otherwise what will happen, it has a track and thus it has got a resistance, and it has got also the value of the ESR. So, we can model it. So, this track resistance and ESR should match, otherwise there will be a reflections or EMI EMC problem will be there, and that is also nowadays has to be considered properly. And generally what happen, larger the value of the capacitor, higher will be the CSR. So, for this reason, even though in the same rating the value of the ESR is list in case of the actually electrolytic capacitor, but in this case since the size of the inductor is biggest, value of the ESR will be the least. For this reason, you will find that the order will be reverse. First, we will put a electrolytic capacitor, then it is equal to the impedance matching of it. So, those who are actually designing this actually a PCB layout, this PCB layout's value of the resistances and the ESR value should match, that is the requirement. Then it will be ceramic will be at the midpoint, since it has got a ESR at the middle of the value, and the tantalum will have a highest ESR rating since it is a smaller size, and thus will be placed here. So, configuration will be changed. So, here it will be ceramic, here it will be actually you will have electrolytic capacitor, this will be the ceramic capacitor, and this will be your tantalum capacitor. So, all those features has to be considered, ultimately that will completes your practical aspect of the designing. Another aspect you require to consider while designing an inductor, so what should be the material of the inductor. So, that also we require to think of. Generally ferrite is chosen for the ferrite is chosen for most practical purpose, but if you wish to have a lower losses and all those issues has to be considered, because roll up will be one of the requirement, because you have a overloading requirement. For this in some time we choose a inductor with a different material. So, practical aspects of DSTATCOM is a purview of the power electronics engineers, and it has been successfully implemented in a distribution level. So, thus I conclude our discussions on shunt compensations, and we have discussed first SBC, thereafter compensation property of SBC, then STATCOM compensation of the property of the STATCOM, then followed by the DSTATCOM, distribution STATCOM, and its practical implementation of it in our courses. I hope that you will find this discussion is helpful for your better understanding of the fax devices. Thank you so much indeed for your kind attention. Thank you.